let's just have a look at number 7 on page 66 before we start something new. Okay, so number 7. Find the equation of the tangent at x equals 5. Okay. Right. Now, because this is still not working, I'll have to use my other writing program. If I use this just for today until I fix it, that's okay to see, isn't it?
No.
Yeah, you'll have to make do. I'm sorry. Okay. Is it too faint? I suppose if I use thicker lines, maybe. If I zoom in. Oh yeah. Now we're talking. Ugh, it's ugly. You don't like? Look, just be strong, okay? With x squared. Maybe if we turn the other light off, it will help a little bit. Why not? Oh, so much better. X squared minus 6x plus y squared plus 2y plus 3 equals 0. Okay, so first, actually, could you close the lines, actually? First, the derivative. So that would be 2x. Yes. Hey, come on. Oh, for me? Oh. 2x minus 6 plus 2y dy dx plus 2 dy dx equals 0. So you can say that 2y plus 2, yeah, come on, Malik, dy dx equals 6 minus 2x. Cancel that out. 3 minus x over y plus 1. And I don't tell you the y. I only tell you the x. I tell you the x is 5. So, well, you know that you need to use 5, but you don't know what to use for y. This is number 7, Malik, from the last lesson. So if I use 5, I have 5 squared minus 6 times 5 plus y squared plus 2y plus 3 equals 0. So I get y squared plus 2y. 25 minus 30 is minus 5. This is minus 2. So this is y. Oh. It's ugly, yeah? Yeah. So y equals minus 2 plus or minus square root 4 plus 12, is it? 12 here? B squared minus, 12. Is that right? So that's minus 1 plus or minus root 3. Now, I tell you that y is between minus 1 and 1. So, we must take the positive, yeah? Yeah. So, this equals 3 minus x over minus 1 plus root 3 plus 1. Which is minus 2 over root 3. So we know that we have y equals minus 2 over root 3 x plus c. So finally, to find the c, we have to use our point. Our point is 5 and minus 1 plus root 3, and then we put in the 5. So what do we get for C? Something ugly as well. Anyone have it? Yeah? 16 over 13 over root 3. Yeah, x is 5 and y is the minus 1 plus root 3. So that goes back in for C, and our answer is y is minus 2 over root 3 x plus 13 over root 3, which is not the answer at the back, is that right? Of course not. Of course not. Let me fix it so. Okay. Maths part 2. Further differentiation, and then implicit. Okay, so while I'm just fixing that, have a look now. We're moving on to a new chapter. We're going back to integration. Can I remove this? Yeah? Is that yes or no? I can remove this? Yeah. Well, maybe I... Is this the answer you got here? Pony. This is the answer you got? Well, okay. So it's number 7, which is minus 2x plus 10. Can you read the answer to me? Here. Minus 2 over square root 3. And then the plus 13 over root 3. Okay. Let's start the next topic. Right, so we're returning back to integration. So far, we have product rule, quotient rule, chain rule, and implicit derivatives. So we have 4 extra tools to help us with difficult derivatives. But actually, we don't have anything to help us with difficult integration. So for example, if I said something like this, we all know the answer here. What do we get here? What's this one? Minus cos x plus c. And what would this one be? X squared plus c. But in fact, we don't have any rule for this problem. So although we have a rule for sine x, and although we have a rule for 2x, we have nothing for sine 2x. So we want to look at how we can maybe simplify this problem. Okay, so you don't need to write this down if you don't want to. This is just giving you the idea we're missing something. So there is a way to simplify these problems, and the method is called by substitution. Okay. So the way this method works is it works off the idea that, well, we can just replace the x with something simpler. I'll just give you an example to show you how this method works, okay? But maybe just before I do, the key idea for this, I don't know, let's call this, like this here, f derivative. The key idea for this is you are allowed to go from here to this.
And you have to get?
Oh, don't worry. Well, there's lots to worry about. Let's not worry about that yet. So you're allowed to split it into dy on one side and dx on the other side. You are allowed to do this. It is a little bit like a fraction. So let me show you what I mean. Let's say we have something like integrate sine 2x dx. So what you do first is you say let u equal 2x. So what does du dx equal? What's the derivative here? Don't be shy, you all know what it is. It is 2. So if you go back here, you can change this into sine u dx. But there is a big problem. Here is u and here is dx. And this says integrate for x, but you have a u, and this is the problem. But if you look here at this, you can split this into du over 2 equals dx. If you just bring this up, do a swap. And you can put that in here. So you can get sine u du over 2. Or if you want, that's a half sine u du. Now you can integrate. This is just like sine x. There's no difference. I just called it u instead of x. This is just like sine x dx. Instead it's sine u du. But it doesn't matter. I mean, this here, sine x dx, is exactly the same type of problem as this sine u du. There's no difference. So what do I get? If I go back up, what does this become? A half minus a half cos u plus c. So there's only one step left. What do you think that is? Change the u back to the 2x. So the answer is minus a half cos 2x plus c. No. I believe I did it right. No, they don't really expect you to check in the exam either. You can if you want. So that's our first kind of simple enough example. Let's do something else. Continue? Yep. Now the big question is, what do you let u equal to? So sometimes it's pretty clear. Can I remove this? Yes?
No, I'm sure.
Hang on, let's see if I can bring it back. Redo, yeah. Control Shift Z. Control Shift. There we go. Dun, 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 dun. There. So, what do we make u equal to at the start? Sometimes it's pretty clear, sometimes it's not. So, let's do another example where it's clear. Continue now? I can remove it? Okay. Okay, let's say we have something like this. X e x squared dx. Yeah. So what do you think we should let the u equal to here?
U equal
X squared, yeah. Usually you'd get the u equal to the inside piece. So here we say let u equal x squared. So du dx would equal 2x. So that means du over 2x equals dx. So we can take this, and we can take this, and we can put them both back in. So this becomes x eu du over 2x. Now there's a problem. You cannot mix x and u. You should have only x or only u. But the problem here is not really a problem because this x cancels this x. So you're left with a half eu du. What would that equal? A half eu just yet. Plus c. So finally the answer is a half ex squared plus c. Yeah? Continue? Okay. Not yet? Okay. I'll give you two to try. An easy one and then a more difficult one. Continue, Malik? Yep. Okay, I'm removing this. Yes? Okay. Right, so let's say I'll give you this one. And I'll get you started. What should you let the u equal to help you here?
2x plus 3.
2x plus 3. Okay, try this for me. Can I do a full screen? Oh, oh wait, is that easier to read? No, you don't like this. Okay. Yeah, it's like a blackboard. I don't have a full screen. Oh wait, there it is, full screen mode. Yeah. Yeah. Some people finished. Some people look confused. Finished? Okay, let's have a look at it. So, du dx equals 2. So that means du over 2 equals dx. So if I go back here, this would be u power 100 du over 2. So this would be a half u power 100 du. That would be a half u power what? 101 over 101, yes, plus c. So this would be 2x plus 3 power 101 over 202 plus c. Yep. Increase the power by 1 and divide by the new power. No. You know this. Integrate x power 4. What do you get? No, that's derivative.
1 over 5.
Yes, 1 over 5 x power 5. Maybe you missed this morning class. No, this morning class. Yes.
If you have like with dx something like x, when you integrate it in the new fraction.
Continue. What's your question?
Like here if you have u to the power 100,
Yeah.
you don't have x. Yeah.
Correct, you shouldn't.
What
The
do
problem.
you have?
It's a problem. It's a problem. We'll look at a more difficult one in a minute. Okay, can I give you another one to try? Can I remove this? Yes? Try this one. And I'll give you a hint. Tan x equals sin x over cos x. And my second hint is you should let u equal to, does anybody know for this one? Well, you've got a choice, 50-50. You either let u equal to sin x or cos x. You guessed correctly. Now in the exam, sometimes they tell you what to use for u, and sometimes they don't. So if you get stuck, you might want to try something different for u. Yeah, okay, try this one. Finished, Roy? Finished? Yeah, maybe. Victor, you're finished? No? Well, John White's not going to be able to help you. He doesn't know what to do, so keep working, please. You two are finished in the middle there? Malik? Where's stuff?
1 over cos x.
Yeah? What's cos x? What's cos x?
Minus sin.
Hmm? Let's have a look. So, this becomes sin x over cos x dx. And this becomes du dx equals minus sin x. So, du over minus sin x equals dx. I can put this and this in. So this will be sin x over u du over minus sin x. Great, because that will cancel that. Minus 1 over u du, which equals minus log u plus c, which equals log u minus 1 plus c, which equals log 1 over u plus c, which equals log 1 over cos x plus c. And if you left the minus in the front, that's okay. That's okay. So that one was more difficult, but something you could get in the exam. Okay, can I remove this? Yep. Nina? Yep. Okay. Okay, try this one. And here I'll tell you let u equal, anybody know for this? You've only got two choices, top or bottom.
3x bottom.
3 plus 4x, the bottom. Okay, try this for me.
How to get rid of x?
Yeah, you tell me. Yeah? Stuck. Which part? There's an X still in it. Yeah. Any ideas how to get rid of it? No? What if there's some way to write X in terms of U? All is lost. Okay, let's have a look at it. So the start is okay. Du dx equals 4. So du over 4 equals dx. That's fine. So this here is 1 plus 2x over u du over 4, which is 1 over 4, 1 plus 2x over u du. Now I think this is where people start to hit a problem. You have x and u mixed together. Did anyone figure out what to do next?
Yeah, you put that down.
Oh yeah, well, I'll give you a little hint.
We get the value of x in terms of u.
Yeah, you look back here and you can say, well, x would equal u minus 3 over 4. So you can put that in here for x. So you get 1 over 4, 1 plus 2, u minus 3 over 4, u du. Now, there's only u. It's messy. We need to clean it up. So if I scroll down a bit, this would be 1 over 4, 1 plus 2u minus 6 over 4 over u du. So what I'll do to clean it up is I'll change this, maybe I can change the color. Doesn't matter. I'll change this 1 into 4 over 4. So then it means I can have 1 over 16, because I can take this out. 4 plus 2u minus 6 over u du. Four minus 6 minus 2 plus 2u over u du. Can you see how I got the 16? The 4 is in common. I factored it out. So now it's 4 times 4. Some people are looking confused here. If I have 1 over 4, a over 4 plus b over 4, I can take the 4 out and just be left with a plus b. So those two I just took out. There's another 4 here, so it made the 16. Okay, any ideas what I can do next? Well, I suppose I can cancel the 2 with the 16 to make 1 over 8 minus 1 plus u over u du. That doesn't look great. Any ideas on what I could do next? Any ideas?
You multiply by
Not quite multiply, but you can divide. You can say this is 1 over 8 minus 1 over u plus u over u du. That's 1 over 8 minus 1 over u plus 1 du. Now we can at last integrate. Equals 1 over 8 minus log u plus u. Yeah? So finally we get minus 1 over 8 log u, which is 3 plus 4x. Yeah, I'll put it in at the very end. Plus 4x plus c. Maybe somebody can tell me why I didn't write the 3. Why didn't I feel I needed to write the 3? Any ideas? Yeah, because the 3 can be just put into the constant at the end. It's not necessary to write it because it's just part of the constant number at the end. Now, if you want to write plus 3, no problem. Oh, sorry, I left out, yeah, sorry. Here, there should be, this is 4 over 8, isn't it? Because it multiplies both. This is probably the most difficult one on the page, but you sometimes get this in the exam in section A. I've seen it 3 times. If they don't have limits, like this one, it'd be 4 marks. Yeah? Okay. Continue? Can I remove this? Not yet.
Why you don't use the previous software?
The previous what?
The previous program. What they used to write.
It's temporarily broken. I don't know what's wrong with it. I need to try and fix it. Okay. Can I close this now? Remove this one? Yeah. Well, I'll leave it there for a second. In this lesson, I tell you what the U is in the questions, okay? But you'll notice that in the next lessons, you're not told this. Usually in the exam, you're not told the U. Only sometimes do they tell you, okay? So for the first lesson, I'll tell you the U in each of them. Okay, so I'll let you try these for a few minutes. These would all be section A questions in the exam.